So hello everyone. Today we're going to make an introduction on Bash and scripting. So it will be a tutorial focused on researchers and the use cases they may need in their work. So it will appear at the very end because this tutorial is not like it's for beginners. There's no prerequisites needed. And we're going to start first with an introduction. So why should I learn batch and scripting? Many times in research, what happens is that we have a lot of data, a lot of files. We don't know where to put them, how to put them, the choices that we have to make for the names, the information we need to put in the files. And that kind of question we always ask. And it's a difficult choice because often when we name or take the decision to sort our data the way they are sorted, it's very difficult to name them again file by file or to change the information inside of them. And here Bash will allow us to do this in a very easy and automatic way. And also for other tedious and time-consuming and also prone to error processes that are usually done by hand, we can replace them by some Bash scripts. So what is Bash? Bash is a command line interpreter for Unix-like operating systems, so Linux and Mac essentially. And in other words, it's an interpreted language like Python for machines, and it helps the machine to operate the code. So if you're on the GitHub page, you can launch the Jupyter Notebook on Binder by clicking on this button here, and it will take a few minutes to load. You'll have the introduction page, and then from the introduction page, you can go to next section. So I'll wait a moment for all of you to have loaded the Jupyter Notebook. And during this time, I'll talk a bit about the keyboard shortcuts. So when coding on the terminal, because that's where we will be using the Bash code, we have some keyboard shortcuts that will make our life way easier, and also we can almost get rid of the mouse. So first thing first, we have the arrows. On the left, it will move the cursor towards the left, and on the right, it will move it towards the right. And when you press the up arrow, it will load the previous command that was typed in the terminal. So here's an example. I open my own terminal here. I just cleared it. So as you can see here, I will type some command. And when I press the left arrow, it will go left. The right one afterwards, it will go right. And if I press up, you'll see the previous commands I typed in the terminal. And if I want to go back to the command that was done after, I just press the down arrow and it works. So we also can directly jump to the beginning of the line or the end of a line if the line is very long and we cannot do that with the mouse. In the terminal, we can just press Ctrl-A or Ctrl-E. So here, if I have a very long command, for example, and I want to go back to the end, I'll press only Ctrl-A and I'm at the beginning, and then Ctrl-E, I'm at the end. And if I want to erase the line without pressing for a long moment on the delete button, I can just press Ctrl-U if I'm at the end, or Ctrl-K if I'm at the beginning. And if you want to see other shortcut buttons, we can just click here and you'll have a cheat sheet of other interesting shortcuts for the keyboard. So I assume that for most of you, the Jupyter Notebook have been loaded. Can you please put thumbs up if it's the case? Okay, perfect. So now we'll start. So here in the first thing that we're going to do, it's the equivalent of the print command. So we'll do an echo it's like print, and we write hello world, and then we'll put shift enter to run the command, and it will print hello world. So that's the base. And now we'll move to navigation commands. So for the commands, for the how it's organized and how the computer is organized, we have the root file up, and then we'll go down in directories and we'll see the items inside of them. So to have a better view of that, we're going to use the tree command. So I pre-installed it. It doesn't come directly with the bash. And here it will show us the files that we have. So the point here is the local directory. It's where we are running our commands. And then inside this directory, we have a notebook that is acres. We have basics. That's also a notebook. We have a directory that is data. And inside this directory, you can also see the other items that are present. And to know what the point is, the right path for the points, which one it is, we just can write pwd, which means print working directory. And we'll see here that since we're in a Docker container and the user is set to Jovian, so we're in home/Jovian. And the first slash is the root, so we cannot go up above that. And now, for example, to see how we can change directory since we are in Jovian home, we can go, for example, to another directory. So if we copy here the path and we put cd, then we paste the path, and we try to go to data molecules. So when we want to complete something that we're writing in the terminal, we can press tab, and it will give us a window with suggestions, or it will auto-complete it if there is no hesitation or other words that could work. So here when we do this, it doesn't print anything. And to see what happened, we do again a pwd. So here we changed our directory and we are in data molecules. So we can also go back to the parent directory by putting the 2 points. If so, the 1 point corresponds to the local directory and 2 points corresponds to the parent directory. So if we go back to the tree, what we did, we were first in Jovian here, then we went to molecules and to data, then to molecules. And if I'm in molecules and I'll do cd 2 points, I'll move up to the parent directory, which is data. So here I did it, and I can print the working directory. So indeed, it is data. And finally, for the navigation commands that I would like to introduce here, we have ls, so it's list. And it will show us the items that are present in the directory that we give in argument here. So here's the local directory. We'll see what we have in data. So we know that at least we have molecules, and we also have sky observation and stars. So it's other folders. And now we'll go to some item manipulation commands. So the first one to manipulate an item is to have the item existing, and to do so for files, we can just touch them with the touch command. So we can name the file whatever we want. For example, here it's my file, and it will be a point text for the extension, so we know it's a text file, and we run the command. And if you do an ls here, we can see that we have the myfile.txt that appeared that was not present before, so we just created it. And if we want to read it, we can use one of the 2 commands. So we have the cat and we have the less. So the difference between these 2 commands is that cat will print the whole text on the screen, even if it leaks out. Whereas less will print the text screen by screen, and you'll be able to, it's more human friendly. So here, for example, if you want to see what we have inside of our file, so my file dot text, nothing happens because the file is still empty. So we need to write something in it. For example, here we can copy what's suggested in the tutorial. And then try to read what's inside the file. So we'll do cat myfile.text, and we'll have the following command here. So that's the line that we have written, the cake is a lie, and we can read it indeed. And now we'll see another way also to write inside a file. So we have two ways to do it. The first one, as we saw, is just to use the greater sign. And now the second one is to use the 2 times the greater sign. So here, we're going to see what's the difference by checking it. So I rent a first time, then I rent a second time. And if I write cat myfile.text, we'll see that we have 3 times the cake is a lie. Whereas if I run it with just the single use of the greater symbol, and then I try to read again what's in the file, we can see that it is only printed 1 time. So can anyone tell me what's the difference between the 2 symbols?
Yeah, it's appending and creating a new one.
Exactly. So the first one here will erase what it will overwrite what was written before, and the second one here will append. Okay, now since we know how to create files, we can also try to create a directory.
Will
So
it, sorry, Fadi, will it always append to a new line, or is there a way to keep going on the same line?
I think we can change this in the options. So I'm going to go to the options later, but I didn't see for this specific command. I can see it later if it interests you.
Oh yeah, just a curiosity. Okay.
Oh, okay. I think there should be some option that you add to the command, and you will be able to change the way you append your new text. So here we're going to create a directory, and the directory creation command is mkdir. So mk it's make, and dir it's directory, and we just have to give it the name of our directory. So we can either write mkdir and then the name of the file. So for example, here my dir, or we can also give the path where we want to put the file. So we can say, for example, it's a bit redundant, I want to put it in my local file, and we create the path. So now we can also check the creation by doing an ls, and indeed we can see that we have my dir here. Now we can try to put the file that you created in this directory. So we will first copy it by doing cp, so copy. We start by giving the file that you want to copy with the path of this file. So for paths, I'll go later to it, and it's either we have a relative path or an absolute one. So in the example here, I'm going to write the relative one. So we suppose that you are in the home Jovian file. No, here, sorry, we are not in the home Jovian file. We are in the data file where we created everything. And from this file, we're going to precise the other paths to what do we want to copy and where do we want to copy it. So here we want to copy my file, and I want to place it in my directory with the name of my file.text. and I run the command. So here, if I do an ls of my directory to see what's inside of my directory, we can see that we have correctly copied the file. And now we imagine that we want to rename the file. So it's almost the same idea than the copy part, but we'll be moving the file with the move command mv, and we'll move it to the same directory. So basically, we'll be just changing the name. So here, my file, I can change its name to my new file, for example. And we can delete the old file since we don't need it anymore. So I can just do rm my file .text, and it will delete the file. Oh, since we renamed it, I should write my new file. So now it's gone, and we can check that by doing an ls. So we don't see the file anymore. And imagine now that you want to delete the directory. So we just try to write remove my directory. And it doesn't work because it's a directory. So what we have to do here is to write the following command. And it's remove -r. So it's for recursive. And we give the directory we want to remove and run the command. So here it just disappeared, and you can check that with an ls. So that's it for the file modification commands. But we noticed that with commands, as I was answering Isabella earlier, we can also add options like for here, the -r, which tells the remove command that it's a recursive operation, and it has to do it for all the items inside the item we're removing, and that's how we'll delete the directory. So more generally, we have also options for almost every command, and there's a convention that is not always applied, but the convention is we use a single dash for one letter option, and we use a double dash for more than a letter option, like for example, double dash option. And sometimes it's overloaded, so we'll have a -h or double dash help for the same command. And also be careful, it's case sensitive. And one more thing, if we are writing many options with a single letter, we can concatenate them. For example, here -o, -m, -g can become -omg. And that's it for the commands. So if we want to see other commands, or we want to learn also about commands, we can go to the manual. So here we press on the button, and it will open a terminal where we can see how we use the manual, because you cannot use it in a Jupyter Notebook. It will freeze it. For example, here, if I try it on my own terminal, and here we can see the documentation. So the name of the function, how it's used, the description, and also all the options and what they do in practice. And once we're done navigating with that, we can either navigate with the arrow or with the enter, with the return button. And to quit the manual, we just press Q. And of course, we can do a recursive man of man and see what it gives. It will explain to us how the manual works. And you can see the different options. So these are the commands that I'm going to introduce in this section. Now let's move to the pipeline and filters. So it's one of the main advantages of the Bash world. It's the pipes and the pipelines. The idea is that we have many elementary commands, and we would like to assemble them in order to have more complex commands in an easy way. To illustrate the concept of pipeline, we'll start with the example here, and we'll run each cell, and we'll try to guess what the final cell does at the end. So here we're listing with L and H. So L will give us the size, it means long, it will give us all the details of the items we have. And H, it means a human, so it will make it human friendly, and it will give us the size of each file and the directory in kilobytes and bytes. So here we see what we have in our folder in molecules, and then here we added the option capital S. So can anyone tell me what's happening here in comparison to here, if you look at the data size?
It's order.
Exactly. So here the S ordered the files, and now we can see what we can do once the files are ordered. So we'll use the command head, and the dash n will tell us how many of, so head will give us the top lines of a file. And here we're saying we want the two first lines. So we obtained total and the first line that's printed. And then here after head we'll do tail, so it's the reverse. It will give us the last line or the n last line. And finally we'll use the function cut. Dash d is the delimiter, and here the delimiter is a space. So we're telling the command that each time it sees a space, it will cut it into fields. And then we do a dash f and we precise which field we want to extract. So here it's the 14th field. Okay, so it's changed between Mac and Linux because I was testing it on my computer. So here it's dash f, which is the 9th field. And we obtain so the file that has the file octane, which has the biggest size. And we did that using pipes and elementary operation each time. So the idea of a pipe is to make complex tasks, and the whole thing here, for example, is a pipeline. And each command is called a filter, and the pipe are the vertical bars which will connect the output of the command on the left to the input of the command on the right. And it will connect it as a kind of a text file input to the command. So now here we have an exercise. And the idea of this exercise is to modify the code cell here. So it will output the text file with the biggest number of words in the file biggest dot text. And here we have some hints that will help us to do it. I'll give you 2 minutes to think about it, and then if anyone has a solution, we'll see what the solution is, and if not, I'll give the solution. And also here I introduced, so it's like the pipeline, but it's a bit different. It's called command substitution. So here command 2 will take the output of command 1 as input, but it won't take it as a text file. It will take it as a list of arguments. And that's the main difference between the two way of connecting commands. Okay, so I'll start explaining the code that we have, and I'll give the solution while explaining the code. Here we use the function WC, which means word count. And we use the option -w, which means word, so it will count words, because usually word count, if you use it as it is, it will count the words, the lines, and the characters. So for example, here we'll see what kind of file we have. We have octan, for example, and we'll do word count octan.pdb. So it will output the number of line, the number of words, and the number of characters. And we would only like to have the number of words, so we'll do a -w. And here we have 246 words inside this file. And what we're going to do here is not only to give it one file, we'll give it a list of files. So for each file, it will tell us the number of words it has. And to do so, we're going to do a dollar between brackets. So it's a substitution. And we'll list all the files in the directory. Then we're going to sort them. So if I sort them like this, what's happening is that we don't have a numerical sorting of our files. We have an alphanumerical one, as you can see. So we have to precise that as an option and put a -n. And now it works better. As you can see, the biggest file is the second one from the end. So we should use the tail command. And we want the last two, the last two items, the last two lines. And now we want the first line of the last two. So we'll do a head, which one? And now that we have what we want, we can place the file in biggest .text. So if you want to look back at the solution, you can also double click here for the answer. And now we're going to move to the next section, which will be the bash scripts and how to put all of the commands that we saw now into code. So just like Python, bash is interpreted. So each time you write a line, it's run in the console. Or we can write also a script, and run it once at a time. So we'll start by writing a simple script. And the script is the same as we did earlier, so it will be hello world. To do so, we will use the function echo and put the output in myscript.sh. So .sh is the extension for bash scripts. And as you can see here, so we have 2 times a call for echo, but it will treat it as a string, and it will not see it as a function here. And we can run it. So now if we try to list the things we'll have, we'll see that we have my script here. And to run the script that we just created, we need to write bash. So the terminal knows it's a bash file, and it needs to use the bash interpreter to run it. And we write my script.sh, and we get hello world. Now we're going to see another concept that will be useful also for scripts. It's the loop. So I'm going to just start by explaining the loop itself a bit. It's very similar to the loop in Python and in any other programming language. And that's the syntax is the following. So for item in list, that's what we write first. Do, and then we enumerate our operations by putting by putting the point virgule, and then we finish that by writing done. So if we want to use the variable item that we have declared in the list, that we have declared in the loop, we have to put a dollar in front of it, otherwise it will be interpreted as a string that spells item. And also, if we're putting an echo for a dollar and we want to print a dollar, we have to put the backslash just in front of it. So for the first exercise, we'll complete it together. So here we want to write a code that prints all the digits from 1 to 10. So first things first, we're going to create this file. I'm going to create count10.txt. And then we're going to start another command. So we start the echo. And we will write our for loop here and complete it. So here the variable that we are using is I. So for I in, and here for the list, how we want to do it. So we'll put it between these curl braces, and we'll put the delimiters. So from 1 to 10, we'll put 1 to point 10, and then we'll close it. And we'll start doing our operation. So for the first operation, we write a do. And then we will print the number. So it will be echo $I. And since we're putting it inside a bigger echo, we're putting the backslash so it can print. And we're going to put all of this inside of counter dot. So here there's a typo. It should be .sh, and we're going to run it. And we're going to see if it's working. And indeed it does. So for the other examples, we have also the arguments. So far, we have written the script with .arguments without changing them or being able to change them. If we would like to change them, there's two main type of arguments. There's the items and there's the list. So for items, there's the code 1 that is an example, which will count the items in the directory. And here the argument will be the directory. As we can see, the argument here is $1. We'll start by listing it, and then we'll use this as a pipe to put it as an input for the word count. And we'll count the number of lines we have, which will be the number of items we have in our directory. Then the second code will be about making a copy of supposedly processed files or just handling a list of files in input. So here we'll do for file in $at, and so the at means that we have a list. We'll do a copy of the file that we have, and we'll name it processed file. So here the guillemets that are for the dollar file are very important in case we have a spacing in the name that we're dealing with for the folder. And it will help us to avoid a lot of issues. Then once we are done from the loop, we just write done. And for the code, we'll echo done to know that it stopped executing and everything went well. So now we're going to start with the first code. We're going to create the bash script, the file, and then we're going to fill it. And also we can add a command or tell the user how it should be used. So by convention, we write usage, then the line of code that should be written in the terminal. So here we should write bash, the name of the script that we have, and precise the directory. So for the example here, I gave the local directory, and it says that we have 15 elements in it. And we can see here that we have 3 by 5, which is the right count. Then for the second code, also we'll create it here. We'll start by touching the file and then echoing into it the lines that we need to put. and we'll see so if it works. It's done, and there's two items that were not being able to be copied because they are directories. And here we're going to list what happened. So we made a copy of all the items that are not directories in home Jovian. And as an exercise for those who are interested in bash scripting, you can try to create a script that writes the letter within a range given by the user. So we'll put two arguments. So it will be $1 and $2. And the output must go in letters.txt. So also to create a range of letters, it's very similar to for creating a range of numbers. And we can just do something like this here with the C and V. It will enumerate all the letters from C to V. And now finally, we're going to see the screening and how it works. So screening is also sometimes we need to install this command. It doesn't come on all the machines. However, it's very important, especially when you have a distant work. And also this part also was written fully by Julien Girard, which is not here today, sadly, to be with us for the tutorial. And it's very important when we are running some routine on a distant computer and we don't want to keep our own machine on. So we can just run the process there and keep it running without having to be to it to do so. So it has many advantages. It helps to reduce the instability of the connection. Also, it's flexible for the process managing. And it's better than doing other dirty parallelization as using the AND symbol or other stuff that I won't mention in this tutorial. So for the demonstration, I don't recommend to run the scripts here. It's better to open a terminal and to run the commands in it. Because whenever you have interactive commands, it will create bugs in the Jupyter notebook. So here we're doing a fast intro for screens. Imagine I'm connected on my SSH terminal and I want to launch a process that should work for days. I just go there and write the following command. So I'll write screen-s to give it a name. So here it's virtual terminal. And you can see that you are connected to it. And you can write some commands. For example, here we'll print hello world. And then the next thing that we will do is go back to our own terminal, our local terminal. And to disconnect, what we'll have to do, it's either by commands, we can write screen-d for detach, or we can do it with the keyboard as mentioned in the tutorial with a Control-A and then D. So Control-A will let us enter in some sort of hidden menu that will allow us to detach. The terminal is running and you cannot access it, it's not that useful. We would like to reattach ourselves to it. And imagine that for some reason we forgot the name of the terminal we're using, the screen we have. So we can do a listing of the screen with screen list. And this is also an exception for the options. We don't have a double dash for an option that's made of more than one letter. So here we see that the name of our screen is virtual term, and we can reattach ourselves to this screen by doing screen-r virtual terminal, and we're back at it, and we still have the hello world command. And to see by ourselves that it will still be running, we can run an interesting command, which is basically making a timer. So we can write the following. For I in, we'll give for 100 iteration. So we write do to start our loop operations, and what we want to do here is to print the value of I each time. So we add $1 to say that we're accessing the variable, and then we make it sleep for 1 second so it doesn't print them too quickly, and then we say that we are done, and we launch the command. So here every second it will print the values, and we can detach our screen. So Control A D. Here we are detached, and we can wait for a while, and when we will attach ourselves back again to the screen, we can see that it keeps on counting. So when we detach, it was at 12, and now it's at 30. And to stop the process of the screen, we can see the number of the process, which is written here after we did screen list, and we can kill the process and stop the screen. So here it's 28, 26, 7. And when we do a screen list to check, there's no screen found, and we successfully killed this poor screen. So for the rest of the screen part, there's more content to it, but I doubt that we'll have time for it, since we're going to discuss a bit the other topics that we could have explained, which are beyond the scope of this tutorial that's being done today. Interesting things which are arithmetical operations. We cannot directly perform them in the terminal. We need to put some extra commands. Regular expressions, they are very important when you are searching for specific type of files or specific type content in our files to replace them. And then we have our bash profile. So the bash profile, every time we start the console, it controls the variable that are here by default, and we can change them and add aliases to them. So once we add an alias, we have some sort of a command that has a short name. So here I have EBP for edit bash profile. And when I launch it, it will open an Atom editor page with the bash profile. And we can see that we have the aliases defined up there. So I'll zoom in on them. And we can see the EBP here. So every time I write EBP in the terminal and I launch it, I'm basically writing Atom dash bash profile, so the path to the bash profile. And even the Atom is an alias that is defined here. So it will open the Atom editor with the bash profile. We also have the shebang. So we have seen that you can write scripts, and every time we have to say that it's interpreted in bash. We can do that in a more simple way and elegant way. It's to put an additional line on the top of our script, and we can just run the file as it is without precising anything other than doing a change mode for the file itself and making it an executable. So here there's many complex content, which is very interesting, and you can read more about it in the resource section. And that's it for today. I hope it was a useful tutorial for all of you, and thank you for listening.